Good morning. This is a special presentation for the DBA Fundamental Group. We have a member of the SQL Tiger team, Microsoft's, oh shoot, hold on a second, lost my screen. Okay. And we didn't do a lot of preparation for this, obviously, but you don't really care too much about us making a long introduction, so I'm just going to make it quick and short. We have a member of the SQL Tiger team, like I said, Pam Lahoud, that's going to talk to us today about modernizing on SQL Server 2019. She is actually responsible, as you can see, for the storage engine area, but she's for the program management of database engine features for in-market and vNext versions of SQL Server. Anyway, one more thing. We have a discount code that you can use, and it actually brings us money and things that we can do with the chapter. So we also utilize this discount code if you want to sign up for Past Summit. Everybody that signs up for Past Summit using our discount code, which will save you off the top $150. Everybody has that, but we have an extra thing we do to where we draw and give away money. We'll be giving away a $300 Visa card at the end of September the 19th or September the 14th. And everybody that uses our code will be eligible. So if you're going to Summit, the smart thing to do is to use somebody's $150 discount code. And since we're giving money on top of that to help with your other expenses, I think it's a great idea to use ours. Okay. Now that I bumbled through that introduction, I'm going to turn it over to Pam.
Thanks, Steve.
I told you it was going to be short and sweet.
Perfect. All right. I guess I need to show my screen again, yes?
Mm-hmm.
Okay, let me do that. All right. Are you seeing that, Steve?
Yes, it looks good.
Okay, great. Well, good morning, everyone. Thank you for joining. And yes, as Steve said, I'm a program manager with the SQL Server data engine team, and I'm on the team called the Tiger team, which is responsible for servicing releases and for in-market releases. And what I wanted to talk to you a little bit about today is some of the new features in SQL Server 2019 and a little bit about modernizing your applications and your servers on SQL Server 2019 and what that brings to you. Okay, so as we're thinking about the changes that we're making in the data platform and how you can modernize onto this new data platform, we're imagining ourselves as Wide World Importers, which is a company you may have seen before in lots of our sample databases and sample applications that you can get on GitHub. And so we're thinking about what are the challenges of worldwide importers that's currently running on, let's say, SQL Server 2008 R2, and what are some of the things that they're thinking about as far as modernizing. So they have a mixture of 2008, 2014, and 2016 servers. So as they've had new applications come in, they may be using newer versions of SQL Server, but they still have a mix of these older and newer versions, and they still have a need to kind of consolidate onto a consistent platform. They have very expensive ETL applications for data sources outside of SQL Server, so they're doing a lot of data movement between, say, Oracle or even, file system, things like that. They've got all these different data sources and they're trying to consolidate them into SQL Server for reporting, but that's a very expensive and hard to manage ETL application to get all that data from one place to another. They're thinking about big data. So should we dip our toe into the big data pool, and what does that look like? We have a lot of legacy code that's around, and maybe it doesn't perform as well as it should. And doing that job of query performance tuning, if we have our DBAs do that, it's expensive and it can take a long time. And it's challenging work that not everyone has the ability to do. We also have perhaps older hardware or, not enough memory, things like that. So we may suffer from I/O performance issues. We also have to worry about security. We need to think about things like GDPR and compliance. And we perhaps have some PII in our database. In fact, I would venture to guess most companies have at least something that could be classified as PII. And so we need to think about classifying our data, auditing. We, of course, have some very business critical applications. They need better availability and less downtime. We don't have only Windows. We have a mix of some different operating systems. Maybe we have both Windows and Linux, and we have that expertise in-house. And we may want to, think about running SQL Server in different platforms. This whole container thing is exploding lately. What does that look like? What does that mean? How can we leverage containers to be more agile, to be to have better availability, perhaps? What does that look like? How about the cloud, right? So we're all on-prem now, but maybe we're really thinking about moving up into the cloud and freeing up some of our resources from the day-to-day maintenance to allow them to focus more on design aspects of our applications, on things like performance tuning, other things other than simply running backups and troubleshooting hardware issues. And maybe I want to think about even intelligent applications in AI and machine learning, because that's the hot new thing, and really it's the future of our applications. We've spent all this time managing this data. What do we want to do with it? How can we take the data we have and turn that into an opportunity for either new business or to just make our business better by leveraging things like AI and machine learning on this massive amount of data that we've collected. So we know we've been holding it for a reason. Now we really need to make it work for us through AI and machine learning. So those are some of the things that you might be thinking about when you're thinking about modernization. It's not just about how do I upgrade this server? It's about how do I really take advantage of all these new technologies that are out there, and how can I make them work for me to make my application run better and to open up new opportunities for my business. So we're talking about older versions of SQL Server here and how we can move them onto a new platform. So we've typically talking here about 2008 and 2008 R2. Obviously, we're talking about that a lot because end of support is coming up in a couple of weeks. So we really need to be making sure that we're moving off this platform, else we have to be looking at some sort of an extended support agreement. So that's, the big one. And of course, 2012 is already out of mainstream support, and SQL 2014 is coming out of support as well. So even though SQL 2014 is maybe a more modern application, we have the new like query optimization in there and things like that. It really, you have to think about, if you're moving off of 2008, where are you going to go? And you probably don't want to go to 2014 because we're considering that not necessarily a modern version of SQL Server. So where are you going to go? So of course, your first choice is to stay on-prem and to move up to 2016, 2017, or 2019. If I were moving up to a version of SQL Server today, I would probably not consider 2016. I would go straight to 2017 or even 2019. We're already out with CTP 3.0, which is available for production support if you choose. So as far as your ramp for how much support you have, it's probably best to go straight to 2017. Or even 2019. And with 2017 and 2019, you have a choice of platforms. So you can see here that runs on more than just Windows. It runs on containers, it runs on Linux, it runs on Kubernetes. So you have really more choices and more options when you move to those modern versions, 2017 and 2019. So that's the on-prem version of SQL Server. And then, of course, we have Azure. So depending on how much you want to manage, you can choose anywhere on this spectrum. So you would have to manage everything if you're on-prem, but you'd also have the opportunity to move into Azure Virtual Machines, or IaaS, Infrastructure as a Service. And in that case, you're fully responsible for SQL Server. You install it, you manage it, but we take care of the hardware for you. So you're running a VM in the cloud. And then, of course, you've got our PaaS services, Platform as a Service, Azure SQL Database, and Azure SQL Database Managed Instance. So Azure SQL Database for just a single database or standalone database, and then Managed Instance would be closer to a full instance of SQL Server with multiple databases and cross-database queries and things like that, but still in a PaaS service where we handle everything for you. So here we're handling backups and high availability. All of that is handled for you. In Azure Virtual Machine, you're still handling those kinds of things like backups, like high availability and things like that, but we're just managing the hardware for you. So Azure SQL Database and Managed Instance give you a full PaaS experience. And then, of course, if you're talking more about big data, we've also got Azure SQL Data Warehouse. All of these implementations of SQL Server are the same database engine. So we're running the same code no matter where you run it, whether it's on-prem or in the cloud, it's the same engine. So you really do have options to move to any one of these in order to modernize. And most of these you can do with little to no code changes. Okay, so let's dig into SQL Server 2019. So the first thing we want to talk about is if you're on one of those older versions of SQL Server, there's so much innovation that has happened between SQL Server 2016 and 2019. And so all of the features that we're introducing in 2019, many of them are simply the culmination of a journey that started in 2016 or 2017. So the first pillar would be performance. So things like the query store, adaptive query processing, automatic tuning, column store and in-memory OLTP, and a bunch of engine improvements that we put under this "it just runs faster" umbrella. These all started in 2016. They're moving, they're getting better in 2017, and then in 2019, we're just continuing this story, adding features to each one of these areas and improving things as we go. For security, we started with always encrypted, row-level security, dynamic data masking, these things coming out in 2017. And again, we're taking all that to the next level in 2019. Availability, so clusterless availability groups, distributed transactions within availability groups, resumable index maintenance, the ability to pause an index rebuild and then start it again later so that you can manage very large databases over time. So again, these are all having to do with improving your availability, and these started in 2017 and we continue in 2019. Some developer features, JSON support, so the ability to return query data as JSON, and the functions that go along to create JSON strings and interpret JSON strings. Temporal tables to be able to manage historical data as well as current data in the same, by using a single query language. And then graph database in 2017. And then last but not least is, of course, thinking about taking SQL Server to wherever you are with Linux and containers, so support for Linux and Docker containers, and then machine learning services with R and Python. So these are some of the great innovations that came with 2016 and 2017, and that story will continue with 2019.
Pam,
so, yes.
One quick question, since we're in this very area. One person asked for Azure SQL as a service. Can you set the database compatibility level to 150 right now and get some of the 2019 features?
Oh, can you leverage compat 150 in Azure SQL database? I am not sure what that would involve. I think it might actually involve getting connected with one of our PMs here. Do I have a way that I can follow up with questions after the talk?
Yes, as long as they give us the right to use their email, we can do that. So.
Okay, all right. So if you want, I can. If you just make a note of that question, I can follow up afterwards and find out what you would need to do to be able to run that.
Okay.
Okay. So SQL Server 2019 now with big data clusters. We'll talk a little bit more about big data clusters later on in this session. So these are the pillars that we're focusing on for the 2019 release. So intelligence over any data, being able to query data wherever it is, using SQL Server, which you're used to using, but also leveraging some of these new technologies like Apache Spark. And so Spark built into the engine, but also the ability to query disparate data using T-SQL. Choice of platform and language. So you choose how you want to work with your data in SQL Server. So first of all, where do you want to put it operating system-wise? Linux, Kubernetes, Docker containers, Windows, of course. And also, how do you want to write your code? You can use T-SQL that you've known for a while, but we now have extensibility within the engine that allows you to use your language of choice, be it Java or Python or Ruby or .NET. All of these things can run within the SQL Server engine. Industry-leading performance. So again, benchmarks, you've probably seen lots of these. So we're always hyper-focused on not only maintaining performance with adding features, but improving that performance over time. Most secure over the last 8 years, and also reporting with Power BI and Report Server. So rich reports across your data using Power BI. In memory across all workloads, so we have all different kinds of flavors of in-memory technologies within the engine, and we'll talk a little bit more about those today. And a consistent data platform that runs across private cloud, public cloud, hybrid, wherever you want to run SQL Server, it is the same engine, and you will have a consistent experience no matter where you take it, all at, of course, the little marketing at the bottom, 1/10 the cost of Oracle. Okay, so what's the key new functionality in SQL Server 2019? So first is what we call data virtualization. So this idea of querying data where it's at rather than spending a huge amount of time and money building complicated ETL solutions. So you have data in Oracle, in other SQL Server database, in SAP HANA, in MongoDB, and Cosmos DB, wherever you have it. We want you to be able to query it where it is rather than having to move it into another SQL Server database in order to query it. So that's the idea behind data virtualization, and Polybase ++ is what Bob Ward likes to call it. So the next version of Polybase, and big data clusters as well. We also are furthering our intelligent query processing journey. So we introduced some of this in 2017 with things like adaptive query processing, but we're just taking that to the next level with some new features that allow the engine to sort of adapt to current conditions and to be more intelligent about query processing. We'll talk about some of those. And then along with that, under the performance umbrella is in-memory database. So we've talked about in-memory OLTP in the past, or also known as Hackathon. That's one aspect of it, but there are a lot of different ways that we're leveraging memory and this new hardware that we have available, such as PMEM devices, persistent memory, to make lots of things run faster in memory. As far as security, we had secure enclaves coming, or sorry, we had, what am I thinking? Encryption in, yeah. Sorry, the feature just flew out of my head. Anyway, so the next level of encryption here, using secure enclaves, which is a way for us to be able to do more with the data, even though it's encrypted. So it's a way for us to be able to decrypt that data in a secure enclave so that we can do more things such as fuzzy matching, doing likes, doing sorting, things like that, which we can't leverage normally with encrypted columns. Always encrypted, thank you, sorry, that's what flew out of my head, always encrypted. So this is the next generation of always encrypted. High availability, so a lot of new options for high availability using Kubernetes and OpenShift, so leveraging containers. I have, if you've built an availability group in the past, it can be complicated and it can take a lot of time to set up. Kubernetes is amazing. I mean, you can run like one command and it builds a whole availability group for you. It's incredible the speed with which you can deploy it. And you've got a lot more flexibility on platform there as well. So high availability options that don't necessarily involve Windows clusters using Kubernetes and OpenShift. Built-in machine learning and extensibility. So we already had R and Python. We're introducing Java and .NET Core into SQL Server, but we've also introduced an extensibility framework that allows you to load your own languages. So whatever language it is that you want to run, we've made the engine extensible so that you can write that code and bring that into the SQL Server engine. And then, of course, as we said, modern platforms. So I've already mentioned, of course, Linux, Windows, Docker, Kubernetes, OpenShift, but also ARM64 with the new Azure SQL Database on the edge. So Azure SQL Database Edge allows you to run this same SQL Server engine on ARM devices. So you can run SQL Server on a Raspberry Pi if you want to. You can play with this stuff today. It's available for you now. So that would be working towards your IoT solutions as well. Okay, so let's start digging into a few of these areas. So performance in SQL Server, as I said, always a key pillar for us. And so we're introducing this concept of the intelligent database. So of course, the biggest part of that is intelligent query processing. I'll dig into that in a moment. But we also have lightweight query profiling. This is a way for you to get execution plans on the fly while the queries are still running. So if you have a long running query, you don't have to wait until the query finishes to actually get the query plan. You can get it while it's running. And this was introduced in 2017, but you had to actually turn it on. You needed to turn it on with a trace flag or by turning on like an extended event. Now it's going to be on by default in 2019. So anytime you need to grab a query plan, you can get one even if the query is still running. So this lightweight query profiling will be on by default. In-memory database. So this is the technologies that we've been talking about. So we're unifying all of our in-memory features under this in-memory database umbrella. And so this includes some things that you may already know, like in-memory OLTP, but it's also got some new things like hybrid buffer pool. So hybrid buffer pool is the ability to leverage persistent memory, PMEM devices, as part of your buffer pool. So the way this works is you just put your data file on one of these PMEM devices, and now your data file itself behaves like it's buffer pool. So we could load things directly into memory if we need them. So the hybrid buffer pool would just be for clean pages. So if we need to modify something, we would pull that into the proper buffer pool. But with hybrid buffer pool, your data file itself is basically just like it's in memory because it's a PMEM device. So super fast performance for I/O. So if you're one of those that are having I/O challenges, you have a very large database that may not fit in memory, you can now leverage hybrid buffer pool and PMEM devices, these new hardware devices, to kind of supercharge your I/O performance. Memory optimized TempDB metadata. This is a way to get around some scalability issues we have in TempDB. So if you're seeing metadata contention in TempDB, then you can turn this on, and this will help improve your throughput against TempDB for very intense TempDB workloads. And we've talked a lot more about that. I've done a few presentations on that, so you can do some searching online and you'll find some more about that. In-memory OLTP or Hekaton, you may know it by, so that's your memory optimized tables. You've had that for a while. And then persistent memory support in other areas. So hybrid buffer pool is one of the areas, but we also have like tail of the log support for persistent memory. So embracing all these new hardware technologies to kind of supercharge the performance of your database. So coming back to intelligent query processing, I just want to dig a little deeper into this because there's a lot that's involved in this feature family. So on the slide, you'll see some of these boxes are in bold. Those are the ones that are new for 2019, but the ones that are not bold are already there in 2017. So this is a journey we started in 2017 with adaptive query processing and introducing things like adaptive joins for batch mode processing and interleaved execution for multi-statement table valued functions. So the ability to kind of improve cardinality estimations by getting feedback, so actually executing a function and getting feedback of that cardinality and feeding that into the rest of the query plan. So this is the first area where we started looking at, okay, we used to just compile a plan and then run it. And there was no feedback after we ran the query plan. There was no feedback that would go back and then maybe tweak the query plan a little bit based on what happened during runtime. All the decisions were made at compile time, and if they were wrong, oh well, too bad. You would really have to go in there and do some tweaking to fix any of those issues. So now what we're trying to do is say, okay, at runtime, we're going to learn things that we can't possibly know at compile time. So what we can do is take that information, take what we've learned at runtime, and feed that back into the query plan so that we can improve the query plan over time. That's what most of these are about. So the new things coming for 2019, table variable deferred compilation. So table variables, we would estimate a fixed cardinality for table variables. We would not actually look at what the real cardinality is, and that could of course cause issues in the query plan. So with table variable deferred compilation, now we're going to wait until runtime to calculate the actual cardinality and then use that when we compile the query plan. And then memory grant feedback, we did introduce batch mode memory grant feedback in 2017, but we're also moving that into row mode as well for 2019. So batch mode is what you get when you use a column store index. So if you've got column store indexes and you're querying against them, some of your operators will run in batch mode. So what the memory grant feedback does is, again, we make that memory grant estimate at compile time, but then at runtime, we look at how much memory did we actually use. And then we can take that information and feed that back into the plan to improve the memory grant over time. So we had that for batch mode queries, but we're now bringing that for row mode queries. So all of your queries against your normal row mode B tree indexes rather than just column store. So the ability to adjust that memory grant over time. Also, batch mode for row store. So batch mode processing is a way where we can process large amounts of data very quickly. So before we had batch mode processing, everything that was done in your query plan is done row by row. So we're iterating over every row. And what that means is the more rows that come through your query plan, the slower it's going to get. Because we're iterating, so we're just going to iterate more and more. So when you start getting a large number of rows, such as what you would get with a column store index, then we really need to look at processing things not row by row, but in batches of rows. And it uses up more memory and more CPU, because if we're operating on a batch rather than a single row, obviously that's going to take more memory. So it uses more memory and more CPU, but it allows us to process a lot more rows quickly. So we had batch mode for column store. Now we'll be able to have batch mode for row store. So even if you don't have column store indexes, if you are processing a large amount of data, we can do that in batch mode, and that's going to get things done much faster. We're also introducing this idea of approximate QP, query processing. So the first feature under this is approximate count distinct. So let's say you've got something like a dashboard where you need to know, you need to count numbers of things, which turns into counting rows in a query, and you need to display those totals on a dashboard. You may not care that they're perfectly accurate. It might be okay for those to be approximate, say within like 1% of what the actual number is. In that case, you can leverage approximate count distinct. And what that does is it gives you a count that's close to the count. It's based on a sampling, but it allows you to do that quicker and cheaper than doing a full, count star on a whole row set. So this is a way you can get approximate counts, which, like I said, may be enough for things like dashboards or for, triggering some kind of downstream processing or something like that. So that's approximate count distinct. And then scalar UDF inlining. So scalar user-defined functions are user-defined functions which typically are multiple statements, could even be one statement, but it returns one value, not a row set. And so the issue with scalar UDFs is that they can be expensive because they run for each row. We have to calculate that function for every row that's being fed into the function. And that can be very expensive because we're having to run that code over and over, especially if the code itself is a query, then we're going to have to run that over and over, and the cost of that can add up. So with scalar UDF inlining, what we do is we try to automatically turn that into a query that can be merged in, similar to a view or an inline table valued function. So a way for us to kind of take that logic and work it into the query itself, so that rather than running that function for every row, we're able to kind of merge it into the total query plan. And this is something that you would normally do manually. If you were having a performance problem from a scalar UDF, you might think about inlining that somehow. But this allows the engine to do it for you. So scalar UDF inlining is another part of intelligent query processing coming in SQL Server 2019. Okay, so these are some of the things that you can expect to see in 2019. And what these do is allow you to improve your performance without actually changing your code, without having to go through those long query tuning exercises. We'll be able to automatically detect some of the most common issues with query performance, and we'll be able to address that simply by upgrading. So just by upgrading to 2019, you might be able to solve a lot of your performance issues without having to do any costly redesign of your application. Okay. So moving on from performance, we'll move into security. So always encrypted, we know, came in 2017. Always encrypted is a form of column level encryption that is done at the client layer. So it's transparent to the database. And all of the certificates and everything exists on the client side, and it's the driver itself that handles the encryption. So no need to make application changes to implement always encrypted. It's all handled by the driver itself. And so the data is already encrypted before it goes over the wire and gets stored in SQL Server. So this also can protect the data from DBAs even, because it's encrypted in the database. It's encrypted before it even gets into the database. So that's always encrypted. So the trouble with encryption is, because we're storing the ciphertext in SQL Server and not the clear text, we can't do certain things like, for example, a like in a query, because I'm not looking at the actual data itself. I'm looking at the ciphertext, so I can't do those kinds of comparisons. I can't sort the data, because the only way to properly sort it would be to actually decrypt it and then sort it and then re-encrypt it. So it can present some challenges with performance, even depending on what kind of encryption you're using. If you're using deterministic encryption, you can say, you know, where one value equals another. But if you're using non-deterministic encryption, you can't even say where these two values equal each other, because two values that are the same are not necessarily translated into the same ciphertext. So it really can give you some limitations on what you can do with that data. So by leveraging secure enclaves, and this is something that it will be supported. You also need to have Windows Server 2019 in addition to SQL Server 2019. But secure enclaves gives us a way to have a secure area in memory where we can decrypt that data in order to perform functions on it, like to do a like operator, to do equality, to do sorting, to do things like, you know, things like that would be perhaps impossible with the ciphertext. We have this secure enclave where we can do that work and then return it back to the client. So this is going to be a way to kind of open up what you can do with encrypted data. And then data classification, we talked about that becoming an issue, especially in the era of GDPR, being able to identify PII and know where it is in your database. So both data classification and auditing built into the engine and built into tools within SQL Server Management Studio. Transparent data encryption scan, suspend and resume. So if you are using transparent data encryption, anytime you turn this on or turn it off, we need to scan the entire database and encrypt it or decrypt it if we're turning it off. And if you needed to rotate the key that was actually used to encrypt the data itself, that would also involve a transparent data encryption scan. And that scan can be very expensive, and it can actually interfere with your regular user workload while that scan is going on. And so we need the ability to suspend and resume, so that you can suspend your encryption scan, you know, while your workday is happening, and then resume it off hours or during a maintenance window. So that's coming in 2019. And also certificate management. So the new configuration manager will have certificate management built into it. So that makes it a lot easier to manage all of your certificates that are used for encryption on your SQL Server. Okay, and high availability, always important for any environment, is at least some level of high availability. And when we're talking about availability here, we're not just talking about like disaster recovery type things like having availability groups or clusters, but also making sure that the database doesn't have to be taken offline for maintenance. So online indexing is a key part of that strategy, being able to still do database maintenance while the workload is happening. So we've got some enhancements to online indexing. Again, we have the pause and resume so that you don't have to get all of your index maintenance done within that window. We can pause and then resume it later. And we also now will have that in 2019 for index creation. So we had it for index rebuilds, the ability to pause and resume online indexing operations, and now we'll have that for index creates as well. Availability groups enhancements. So we do have a plan for system databases. One of the challenges with availability groups is that only the user databases are being replicated. So things like logins and agent jobs would not necessarily get replicated. So we're looking at some way to replicate that data in the system databases as well for your availability groups. Also, availability groups on Kubernetes rather than Windows cluster. So you can leverage Kubernetes to build out an availability group. And we have a diagram of that on the slide here. And I think I might actually have a more detailed. No, actually, this might be the only one. But so the way this works is you have an operator within Kubernetes that manages the failover, the things that the Windows cluster would normally handle. And then you also have a load balancer that is used to direct traffic to the primary instance of SQL Server, wherever that may be. If it fails over to another pod or another node, then the load balancer takes care of that. But you can also have multiple load balancers so that you can use Kubernetes to load balance your read-only connections as well. And so this is all handled by the Kubernetes operators. And so this allows you to build out an availability group quickly and easily with containers on your platform of choice. And then the last bullet here on this slide is accelerated database recovery. And if you haven't heard about this yet, this is some really cool technology. So what they've done here is started to leverage something called the persistent version store. So that's kind of the next generation of row versions. If you've had one of the row versioning based isolation levels like snapshot isolation or read committed snapshot isolation, you may already be familiar with the version store. And the version store is stored in tempdb. So if we've got many different databases on the server, everybody's kind of dumping everything in tempdb. So with accelerated database recovery, we're taking that version store, we're moving it into the user database itself. So we've got this new versioning called the persistent version store. It's inside the user database, so we're taking that out of tempdb, moving it back into the user database, and that allows us to do instantaneous recovery. So if you've ever had a really long-running transaction and you've actually been afraid to kill it because you know if you kill this transaction, you're going to have to roll back the whole thing, and it might take as long or even longer to roll back that transaction than it did to actually do the work it's done. So, I mean, it's always this thing you're staring at it. You're like, is it going to finish? Is it almost done? So now that worry is gone. If you need to kill a transaction, it's done. The rollback is immediate because we just go back to those row versions. So rather than having to, scroll through the transaction log and redo or undo everything that's been done, we can just instantaneously roll back to those original versions. And so rollback is immediate. And that also means that recovery is much faster if I need to restart or if I need to fail over in a cluster. Because again, I'm just going back to those row versions that are in the database. I just instantaneously restore them. So the only thing I really have to redo on recovery is things that were in memory only, things that were in the buffer pool that never got checkpointed. So it's really only that last little bit of the log, the things that didn't get checkpointed that need to be redone at recovery. Everything else is instantaneous. So super fast, both rollbacks and recovery. This is a game changer for availability. So that is available now in Azure SQL Database and coming in SQL Server 2019. Okay, so developer improvements. So SQL Graph database. So Graph database again came in 2017. We've got some enhancements there, some additional syntax that's being supported. Also UTF-8 support. So this UTF-8 support is mainly for folks who need to support UTF-8 encoding, but also it can allow you to reduce the size of your strings. If you're using Unicode strings and varchar strings, especially if you're primarily just storing basic ASCII data, then turning those into UTF-8 strings allows you to store that Unicode data within a varchar. So you can reduce the size of your database significantly if you have a large number of strings. So UTF-8 support coming in 2019. Additional machine learning services. So we talked about, we have had R and Python, but we're now introducing Java into the mix and .NET. And again, that extensibility framework, SQL Server language extensions. This allows you to load your own languages. Whatever code you want or whatever language you want to use, you'll be able to load that DLL into the engine and be able to leverage that language within SQL Server. So for developers, not only your choice of platform, but your choice of language as well. All right, SQL Server 2019 and Linux and containers. So again, we started this Linux journey in SQL Server 2017, but there were some parts of the engine that didn't make it into 2017. So for 2019, we're going to continue adding support for different features within SQL Server, replication, distributed transactions, machine learning, and Polybase, all coming into SQL Server 2019 on Linux. We have a new Microsoft container registry that allows you to pull down containers from Microsoft, and also, as we talked about earlier, availability groups on Kubernetes. So using containers, actually, I think I have a slide on why containers. This is a big question that a lot of people are asking. I hear all this about containers. Why do I care about containers? What would I use them for? Most people are thinking they're really just for development. Why would I run a production server on a container? And one of the things that people are looking into is this ability to be able to take your database wherever you want to go. So portable. If you are running SQL Server in a container, you can run that container anywhere Docker is supported. So that means not only on-prem, but on a cloud, any cloud vendor you want that supports containers, you can run it. And so if you want to move from one vendor to another, you can just take your container and go somewhere else. So this ability to be more flexible in your platform, to be more agile, and the ability to move around. It's lightweight, so reduced disk, CPU, and memory footprint over a full VM. Consistent image of SQL Server scripts and tools. So you can create a container image yourself. So you can take one of our SQL Server container images, you can add your own scripts, your own tools, whatever applications you need to install there, and you can make your own container image and you can roll that out across your environment. So it's a way to have consistency across deployments. And be that for production deployments, or if you need to set up a dev environment, you can quickly and easily spin up a container image and instantaneously have a development environment. And then, it can be reset. If you need a new version of SQL, guess what? You just stand up a new container. All the new code is there. There's no upgrade. It's just start a new container, connect it to your storage, to your persistent storage, and boom, you're upgraded. So there's this whole idea of an upgrade being this huge, complicated process. It sort of goes away to a certain extent because this container, you just spin up a new container and boom, you got a brand new version of SQL. So a lot of options there for flexibility with containers. All right. Oh, I do have a more detailed HA and Kubernetes. Okay, so this is a little more detailed slide on how availability groups work on Kubernetes. So no clustering, just using Kubernetes nodes and pods. So you have the different nodes that host a pod, and then the SQL Server is running inside the pod. These are connecting to a persistent volume storage, which is similar to your shared storage in a cluster. And then you have a load balancer service that is handling connections to the currently active pod, the primary database. The user would connect to the load balancer service. If that pod were to go down, we can start up another pod within the same node. Or if the node were to go down, then the load balancer can automatically direct me to another pod on another node. So the Kubernetes orchestration handles all of this moving around, the things that the Windows Server cluster would normally do. Okay, so Kubernetes failover, okay, operator deployment. So the availability group itself is the same. So most of that availability group code, all of that is in SQL Server. So the only thing different here is really the orchestration of the failover. That's what Kubernetes is handling, and that's what the Windows Server failover cluster would also handle. So it's handling, redirecting the name and handling all of that failover. Everything else is going to be exactly the same. All of your availability group scripts would still work the same. All of the concepts still apply. The only difference is how that orchestration is getting done. And we also then have the ability to have the load balancer not only for the primary app, but also for the secondary replica readers as well. So we can load balance not only the primary application, but any reporting applications that you may have as well across multiple secondaries. Okay, yes, we know how availability groups work now. Same as they would work on Kubernetes. All right, so data virtualization. This is what I was talking about earlier, where we want you to be able to use T-SQL or even machine learning languages in SQL Server without having to move your data. So without having to do expensive, complicated ETL processing, you can query your data wherever it is. So Polybase is a distributed compute engine that's integrated into SQL Server that allows you to query the data wherever it lives using T-SQL as if you had the table directly in that SQL Server database. So it's distributed, scalable query performance. You deploy it with SQL Server by creating an external table that points to one of these other tables. So you can MongoDB, Cosmos DB, Oracle, Teradata, Cloudera, HDFS, Hortonworks. If you've got big data, if you've got relational data, NoSQL data, whatever you have, we can query that as if it were a table in SQL Server. So this allows you to not have to do all of that ETL and still be able to build reporting applications that query across disparate data that's stored, distributed across your environment. So with Polybase, you would have to manually create these external tables, point to the data you want, where it's at, and then you can write these queries against the external tables that would then go out through the Polybase engine and query these data sources where they lie. But okay, and so again, you know, all these different types of data that you have are supported by Polybase. So you have legacy databases that you might be querying. Let's say you've got your existing, you know, stock items here. You've got mobile application orders. You've got a mobile application that's maybe using Cosmos DB. You've got customer data in SAP. You've got account data in Oracle. All of these things can all now be queried by using Polybase in SQL Server 2019. So Polybase requires you to, like I said, manually create those external tables. But with big data clusters, we're talking about adding some orchestration and automation around this to pull in all of this disparate data and add some layers of orchestration and also some layers of optimization using compute pools and data pools. So if you want this, the easiest way to do that, you can just leverage Polybase directly. But with big data clusters, we are leveraging Kubernetes and containers to kind of bring all this together and automate it for you. So we've got this idea behind, so the first data virtualization, the external tables, that's your Polybase. And then the managed aspect of it is the ability to have SQL Server and Spark plus HDFS, and HDFS will actually ship with SQL Server to have this all together in a pod, in a Kubernetes pod, that then you can spin out multiple pods. So this bringing the machine learning and the big data technologies directly into the SQL Server engine. So rather than having to have them separate and build separate applications and learn all that, you can now just bring this all into SQL Server, the power of big data, of Spark or T-SQL, and have it all being managed within SQL Server 2019. And again, bringing in the AI and the machine learning. So machine learning services, Spark machine learning, all directly within the SQL Server 2019 engine. So this is a very complicated architecture diagram, probably a little more than we can speak to in this webinar, but I'll just give you kind of a high-level overview of big data clusters in SQL Server. So as you can see on the slide, we have the persistent storage and we have these different nodes in Kubernetes. So this is Kubernetes orchestration working to manage big data clusters. So then we have our storage pool, which consists of these different Kubernetes pods. So the pod consists of an instance of SQL Server, Spark, and HDFS data in each one of these pods. And so you can spin up multiple Kubernetes pods to build out your storage pool. And then we have a master instance of SQL Server that's used to query all of this. So you can have also the compute node. The master server instance can either read directly from the HDFS storage pool, or you can also have this optional compute pool, which is made up of SQL Server compute nodes. And this builds out your big data infrastructure using Kubernetes. And then you can have your reporting applications, either custom apps or Power BI or whatever, connecting to this master instance and leveraging just standard SQL Server. And then we also have the Polybase out on the side, so the external data sources that you can leverage external tables to query, and or optionally other SQL Server databases. So if you happen to have your own SQL Server data mart yourself, then you can even query that directly, and the master instance can bring all of this together. So this is a way to integrate big data stored directly in SQL Server in these HDFS, in these pods in the storage pool, or querying external data that's stored in other data sources like Oracle or Teradata, and bringing that all together so that you can query it from one place. So we have a single point of access to your entire data estate. Building this all out with SQL Server 2019 and big data clusters. And then, yeah, that's all one cluster. And then there'll be a control plane as well that would help you manage all this. So the control plane would be how you would monitor and manage all of these systems. Okay, so it is quite complicated, but if this, I would definitely encourage you to do some research on big data clusters. Take a look at this. It is very, very cool technology, and it really opens up the ability to integrate and manage and query your entire data estate all with SQL Server, with a tool that you're familiar with and that you already know. Okay. So a couple of other nice little things, customer voice. So we do listen to, especially the Tiger team. The Tiger team's job is to listen to customers and take that feedback and bring it directly back into the product. So many things that our customers have been asking for, we are also trying to implement in 2019. One is some improvements with DBCC clone database, which is often used to troubleshoot performance issues. So to take a production database and bring it onto a test system and troubleshoot issues. So we've added some things around column store to that. Estimate compression for column store indexes. So if you're considering column store indexes and you want to know how much space am I going to save, you can now use SP estimate compression savings stored procedure for column store index compression as well. Diagnostics for auto stats blocking. Also, the #1 voted customer feedback item of all time, the string truncation message. So string or binary data would be truncated. That's the only error message you would get. You have no idea which string or which row or which table. You have no idea what would actually be truncated. It was really tough to troubleshoot that. So new error message for that. String or binary data would be truncated in table blah, column blah, and here's the truncated value. So a way to actually troubleshoot that. Troubleshoot page resource waits with the new built-in T-SQL. So we have, most people are just calling it the page cracker now. We have a new DMDB page info function that allows you to give it a page number or page resource and tell you the header information on that page, so you can tell which object it belongs to. So this is key for troubleshooting any kind of page latch waits. You might be having page-related waits. In order to know what the problem is, you need to know which page I'm waiting on. So page latch waits can be caused by a number of different things. The primary reason for this is because page latch waits are key to TempDB contention. So page latch waits in TempDB might be object allocation bottleneck. It might be a metadata bottleneck. If you're seeing page latch waits in your user databases, you might be having hotspots in your data or last page insert contention. So the only way to know that is to know what's on the page. So this function gives you a supported way to do this without having sysadmin rights, to be able to, in one single script, figure out what page you're waiting on. So that's the page cracker or DMDB page info function. So I got the syntax there on the slide. So you need to use DMDB page info in combination with another helper function called page res cracker. So what we've done is we've added a page resource column into DM exec requests, and it's also in sys.sys processes. So that page resource is a binary value that we feed into the page res cracker, and the page res cracker translates that into database ID, file ID, page number, which are the parameters that go into DMDB page info. So if you were already familiar with dbcc page, if you've ever used that command, this should replace dbcc page for most of your needs. This only gives you the header information from the page. So it doesn't give you the body of the page. So if you need the body of the page, you might still have to use dbcc page. But if all you care about is wanting to know which object this page belongs to, then DMDB page info is what you need. And then the last bullet here is a custom capture policy for the query store. So a lot of folks have started using the query store in SQL Server 2017, but they may find that they want to be a little more refined in what data they capture, how often they capture it. That can have an impact on the overhead of query store, but also an impact on the size of the data, how much data we're capturing within the query store. So we've added some additional policies that you can configure to decide what you want to capture, how long you want to hold it for. So that gives you a little more customization ability for query store. Okay, so we've talked about a lot of cool things in SQL Server. The question is, how do you get there? How do you migrate to a modern SQL Server? So how do you get from your legacy up to SQL Server 2017 or 2019, either in the cloud or on-prem? So we have tools, free tools, that you can leverage to help you with this. So the Data Migration Assistant is a way that you can do an assessment on your current data and determine, are there any things that need to be mitigated before you move? So this will look for things like breaking changes, behavior changes, anything that we've seen that could potentially be an issue on a newer version of SQL Server. We can analyze your code, both static and ad hoc code, so stored procedures as well as ad hoc code, and we can analyze that and look for any potential migration blockers. We also have the Azure Database Migration Service, which you can leverage if you want to move into the cloud. We can basically do that for you. So the Azure Database Migration Service runs the assessment and actually automatically gets your data migrated up into Azure. So if you're moving into the cloud, we can help you do that with these tools. We also have the Database Experimentation Assistant. This is a A/B testing tool that allows you to do some testing to determine what your performance is going to look like on that new platform. So you run the workload on your legacy SQL Server, and then you can replay that workload on your target server, whether that's in the cloud or on-prem, and determine if you might have any performance issues. So Database Experimentation Assistant helps you identify any potential issues before you actually do the migration. You can also do, how am I going to actually get the data over there? The Data Migration Assistant or the Database Migration Service will do that for you automatically, or you can leverage just the same methods that you may have done in the past. either doing an in-place upgrade, doing a backup and restore, doing log shipping, doing a bulk import, doing SSIS. There's many different ways you can get the data from point A to point B. It all depends on how much downtime you can afford and how big your database is, for example. There's different options depending on where you're going, what the destination is, and how much tolerance for downtime you have. And then once you get to the target platform, then we have the query tuning assistant that you can leverage when you get there to help mitigate any performance issues that may occur as you upgrade the database compatibility. So if you're taking a database backup, or if you're doing log shipping or anything like that, when you get to the target database, you'll still be in the old compatibility mode. So what we recommend is you actually run in that old compatibility mode for a while. Let the query store collect data on the old compatibility mode, and then when you're ready to move, the query tuning assistant can actually help you with that. So it'll guide you through that process of upgrading the database compatibility. It'll help you collect data in query store, and then you can have it automatically upgrade the compatibility, or you can do it manually, and then it will continue to collect data in the query store after you've made the compatibility change, and then it can do comparison and analysis on your queries. And the query tuning assistant can help you mitigate any issues that may occur when you upgrade that database compatibility. Okay. Azure Site Recovery is another way it's another thing you can leverage to get up into the cloud as well. And I just noticed that I'm a little bit over time, so I'm going to try to go quickly. And then we also have the SQL Server Migration Assistant that allows you to upgrade external databases to migrate them into SQL Server. Okay. Great. So sorry, I didn't leave a whole lot of time for questions, but if you do have any questions, please do let me know. And I've got a couple of links here for additional information training. Steve, are we going to share this slide deck with them as well?
Yes. Just
okay, great.
It'll be available on our site
at
epafund.org.
Okay, great. So we'll be able to, you'll be able to share this and get these links as well. And other than that, thank you very much.
One other thing, great presentation, lots of great information. There's a lot of questions, and we don't have time for them now, but if people will let me know, and a couple of people have already done that I can send their email address to you, then you can answer them and maybe even blog about it, so other people can get the information also.
Yeah, that would be great. So I'll either, if you can send me the questions, even if they don't want to share their email, if you can at least send me the questions, I can answer them on Twitter, or I can throw out a blog somewhere.
Okay, good deal. And we'll try to let people know where that's at.
Yeah, well, so follow me on Twitter, SQL Goddess on Twitter. And so I will either tweet the questions directly there, or I'll tweet out a link to a blog where you can read the follow-up.
Okay. We will have another session July the 8th with Brent Ozar talking about, I think that's the day that support drops for 2008 R2, and he's going to talk about the different options you have. So be sure and sign up for that. And be sure and use our discount code. And great session, Pam. Hopefully we can have you back sometime.
Thanks, Steve.
Let me enter.
Just wanted to say congrats on the book as well, Pam.
Oh, thank you.
No worries. I have it on my basket, so I'm waiting for it to be delivered.
Oh, great. Awesome. I hope you enjoy it.
I hope so too. I know that I will, though.
She has a book out?
Yeah.
She does?
Pedro and I wrote a book together.
I'll have to look it up.
It's called Learn T-SQL Querying.
Oh, gosh, that'll be great. I'll
and
look that up.
It's got a lot of internals information in there as well about query optimization, so it's not just
I'm trying to really hone my skills with T-SQL, so I'll probably buy something like that. Is it available already?
Yep, it is.
Good deal. be out there looking for it.
Yeah, you can get it on Amazon or actually we created short URLs to it too. It's aka.ms whack learn T-SQL querying.
Good deal. I'm trying to make sure that I have the questions available and everything I need before I get off. Otherwise, I would have already ended it.
Yeah, I'm looking at them now. So do you need me to send you the deck? I don't think I have sent it yet.
Yeah, go ahead and send that to me, and I'll post that up as soon as I post up the video. We're changing the process of the way we do videos, so I got to be sure, but I'll go ahead and upload it. We got a pretty good YouTube site, but they're going to be changing things around where you go to pass to get the information. So I'm not sure when that happens. But
all right, so I'm just going to respond to Sanj's email.
Whose email?
Sanj sent an email to you and me about the webinar.
Okay.
So she has it at pass as well as you.
Amanda was the one that sent it to me, so I don't think I got that one from Amanda Martin at pass.
Okay.
She basically just forwarded the information, forwarded your email on to me.
Okay. Well, I'll just here this.
Oh, so you don't have my email, Steve.Cantor.
I do have your email. Yep, I have it here.
I'm sorry.
No, I'm just trying to figure out which. Let me add Sanj to this just to make sure she's on it as well. All right, this. There. File. Oh, yeah. I gotta get on Power ASAP. Okay. Sending you the deck, so you should have that momentarily.
And I'll send you all the questions and the emails of the people that gave me the rights to do that. So.
Okay, great. And then, so I'll email them directly the answer, and I'll CC you just so you know that I answered them. And then I'll probably just put together. I don't know if it makes sense to put it on a blog, but I might add a forum. I might add a forum post to the tech community. That might make more sense. Either way, I'll tweet it out and just let everybody know.
Okay, good deal.
Answer all the questions. Okay, great. Well, I better run before my battery runs out.
Okay.
All right. Thank you so much for running the show. I will speak to you soon.
Okay, thanks. Bye.
Thanks. Bye-bye.